Hello everybody, we are on day 1 of credit 8, so go ahead and watch the introductory video and make your guess about what you think this is going to be at step 43. Watch the results video and then we jump into the main portion of today. So the I rule. Marco has started a blog about Imagination High School and they have this symbol, the I. And he's working on creating a logo with various sizes to be placed on different pages of the website. So Marco developed the following design. So size 1, size 2, size 3, size 4. How many squares will be needed to create size 100? So you might want to, I'd recommend making a table of values. So 1 you have 7, 2 you have, let's see, 5 is 10, plus 2 more is 12. Okay, and then so on. So do you see a pattern between the steps? That's how I would do that. And then is it a linear function? If so, then you can write the symbolic form of it using how much are you adding each time. That'll be your multiplier in plus the initial condition. So if you can back it up and go to the 0 spot, where does it start at? Okay, that's a little hint there. Yeah, developing the mathematical model in terms of n will be what you want to do there. Okay, then Marco decides to experiment with making his logo blockier so that it looks stronger, and this is what he came up with for size 1, 2, and 3. Okay, so there, now you want to make what does the size 4 step look like? So if you look at this carefully, it looks like he has 7 here, and then it looks like each one kind of blows up, right? So each of those 7 gets 4 more, right? And then over here, each of the 7 gets 9, right? So each of those 1s turn into a 3 by 3, and each of those 1s turns into a 2 by 2. So you can look at it that way, that on the 4 it's going to turn into a 4 by 4. And then you can tell me how many squares there are total. And now making a mathematical model for this is pretty difficult. So let me give you a big hint here, that if you had a square and then it went to a 2 by 2 and then a 3 by 3, this pattern right here would be n squared, right? Because step 1 is 1 times 1, step 2 is 2 times 2, and step 3 is 3 times 3, or 9. So that would be the pattern there. Now we have a little I that has 7 singles in it, and then each of those 7 singles is going to get that kind of a treatment, right? So there would be 4 there, 4, 4, and so on, right? I'll just finish it out here. So can you take this idea and now upscale it to this? So each one of these is turning into a square, right? And so if you can write down, some sort of multiplier, or are you adding, that sort of thing, come up with a formula that would predict the right number in terms of n. And then once you come up with an idea for this, check it on the third to see if you got the same number. So you should make a little table of values for 1, 2, 3, and 4, and see if that symbolic representation that you come up with works for all 4 of the steps. Okay, and then answer the question here. Watch the vocab video. And now we want to look at polynomials and how do we manipulate them. So how do you add things together? That's going to be in the other videos. So you want to write different equivalent expressions of each. So if I have 8 x's, so this could be any number, right? So 8 times 4, right? It could be 4, it could be something else. and then I take away 3 times 4. Is there another way I could write that that would be equivalent, right? And so 8 times 4 is 32, and 12, so 32 minus 12 is 20. Well, hey, that's the same as 5 times 4, isn't it? So 5 times 4 would be another way I could write that. So think about that. Write these different forms of equivalent expressions. So all I did was change the 8x minus 3x is the same as 5x. So this is an equivalent expression, for example. Okay, maybe not the simplest form, right? So there could be other forms that are even simpler than that. Okay. Determine which of the following pairs of expressions are equivalent. So is this equivalent to this? So let me see, 3.2x's plus 5.4x's. So I could add 3.2 and 5.4 and get 6, 8.6. So 8.6x's would be equivalent. So this one is yes. So if the pair is not equivalent, correct the mistake. So I guess you could, if you found one that's wrong, try to figure out why they, or what they could do to be corrected. Actually, this one is incorrect, right? Because I could distribute the 3 and get 3x minus 6, and 6 minus 3x, those are not equivalent. So no. So you have to have the negative on the 6. So this could be equivalent, right? Negative 6 plus 3x would be equivalent. So that's just 2 examples. Now we talk about our good old properties, the distributive property, commutative property. These are just different equivalent expressions that follow the rules of math. So it doesn't matter the order that you add. It doesn't matter if you add this group first or that group first. And then it talks about the definition of subtraction here. So subtracting B away from A is the same as adding the opposite of B. So this is defining subtraction as addition. And then right here we have defining division as multiplication. So A divided by the B is the same as A times 1 over B. So cutting something in half, like 10 divided by 2, is the same as 10 times a half. Okay. And then you're going to be using that to find equivalent expressions with polynomials, because polynomials follow the same rules that our integer friends do, and rational friends as well. Okay, so we're going to expand these forms to come up with equivalent expressions, so using those rules. So for example, we're going to use distributive property. So 4 times y plus 4 times 2. And you could even do that multiplication. So you could say 4 times y plus 8 is equivalent to that original expression. And dividing, remember, dividing is the same as multiplying by the reciprocal. So instead of dividing by 4, I'm going to multiply by 1/4. And then I could distribute and go even further, right? So 1/4 times 16 is 4x. And 1/4 times 8 is 2, right? So 4x minus 2 will be an equivalent expression. Okay, and then factoring kind of is the opposite of distributing. You're actually undistributing. So let's see what can we take out of both of these, or what can we divide both of these by, right? We can divide them both by 2. So if I take a 2 out, and then what would be left inside the parentheses to be an equivalent expression to that. So it'd be 2 times x would be 2x, and 2 times what would give me 6? It would be 3, right? So this is how we do that. And then, so the same thing. What can you divide both of these by? Pull it outside the parentheses, and what gets left inside to make it an equivalent expression? That's the question you ask yourself. Okay, here's combining like terms. So if you have a term that has the same multiplier, so x here and x here, it's the same as just adding those together first and then multiplying. It's kind of, it follows the same rule as the distributive property, so I could take it out, right? I could divide both of these by x, and then I'd be left with 7 plus 11 inside, and then I add the 7 and 11, and I get 18, so 18x, right? And nobody really does the distributive property first. They just add the 7 and 11 together and say that's combining like terms. But that's the basis for it, is using the distributive property to factor it out first. Okay, so write these in simplest equivalent form by expanding, so using the distributive property and then combining the like terms. So I'll just do this one. So 7 times 3y would be 21y, and 7 times minus 2 would be minus 14, and then I still have this plus 6y here. And now I combine any like terms, so I could reorder these two, right, and then add the 21y and the 6y makes 27y's minus 14. So that would be an equivalent expression to this original one. Okay. And more like that. So this one they want you to combine like terms and then factor, so let's combine them. Let's see, 15 minus 6 would be 9 x's, and then 7 plus 5 is 12 singles. And then if I factor, what can I divide both of those by? It looks like a 3, and then I'd be left with 3 x's and a 4 inside to be an equivalent expression. Right, so this is the equivalent expression after I combine like terms and then I factor. So that's what you want to do there. Simplifying, so are these equivalent? So I would multiply this out, so 2x minus 2, see it's not equivalent to 2x minus 1, so it's not equal. And correct the mistake, this should be a minus 2, right? So no, minus 2. Okay, and then you're going to reflect on what you've learned here today in your math notebook, and that's it for today.